Alright, welcome back. I'm going to keep going with free response today. I'm skipping ahead to question 6 so that we can do one of the Maclaurin-Taylor series together. So we're doing general form for Maclaurin series, radius and interval of convergence, working with composite functions and estimating the error, as given here. Okay, so we've got our f of x is the natural log of 1 plus x cubed. And we're also given what the series for the natural log of 1 plus x would be. Okay, the first thing they want us to do is to write the first 4 terms and a general term for the function f, if we were going to approximate it with a Maclaurin series. What would I have to do?
So since the max series for ln 1 plus x is given, we just change x.
Okay, so what's going to happen to my first term?
So it's gonna be x cubed and minus x 6 power over 2 plus x 9th power over 3 minus x 12 power over 4.
Okay, so that's the first 4 terms, and then we need a general term. So in general, this could be what?
So minus x plus 1 is the same. Minus x to the n plus 1 is the same.
Okay, I've got a negative 1 that I'm going to pull out there. So that's negative 1 to the term plus 1, you said.
And then x times 3n.
Okay, that'll work. Divided by...
And then divided by 4. No, n.
Divided by n. Okay, that works. Okay, then we need... We're told the radius of convergence is 1. They want us to find the interval of convergence and then show the work.
So if it's 1, then we plug in minus 1 and 1 for instead of x.
Okay, so that means the center point is at 0. How did you know the center point was at 0?
Because it's just x.
Right, so our general form for a Taylor series is x minus a. Also, a Maclaurin series is a Taylor series that's centered at 0.
Yeah.
So just because it's a Maclaurin series, we know it has to be centered at 0. Okay, so we know that our interval will go from 0 to 1, but we do need to test the endpoints. Okay. So if we plug in x equals negative 1, what's going to happen?
So that's gonna be negative 1 minus 1 over 2.
Okay, so looking at this,
Mm-hmm.
When n is 1, will this function be positive or negative?
1 is negative.
Okay, what about 2?
2 is negative.
Okay, so this function is always negative because either this one or this one will be negative and the other one will be positive, right? So this is the same thing as negative 1 over n. So
Yeah, so that's gonna be diverge by P series.
okay, it diverges because we're not alternating anymore. If it was alternating, then that would change, right? If it was alternating, we would converge conditionally. But because we're not alternating, this one can diverge by P series. Okay, so then I'm going to try plugging in 1 instead.
So 1, it's gonna be x. Then if we plug in 1 for n, then it's gonna be positive first.
Okay, then plug in 2.
2 is 3. Negative. Oh, it's positive, negative. So it converge.
Okay, this one will converge. Converge because the series is alternating and we're still decreasing and past the nth term test.
Yes.
So converges conditionally. By which series test?
Alternating series.
By alternating series test. Okay, we diverged at -1 and we converged at +1. So what should my interval be?
-1 is no, x is greater than -1 but less or equal to 1.
Perfect. Okay, did they ask for anything? Nope, that's it. Okay. Okay, they asked us to justify the answer, so I feel like we've justified down here.
Yeah.
Okay. Part C. Write the first 4 non-zero terms of f prime t squared. And then if g of x is the integral of that, use the first 2 non-zero terms for g to estimate g1. So I'm going to grab our general form of f really quick. Actually, I'm going to cheat again and grab a screenshot, I think, and we'll paste that in. Okay, so this was f. So if this is f, then what are the first 4 non-zero terms of f prime t squared?
So if we derive it first, then it's 3x squared minus 3x fifth plus 3x eighth power.
Okay, got one more?
3x squared minus 3x fifth power plus 3x eighth power.
Okay, minus. Read the first 4 non-zero terms.
Minus 3x 11th power.
Okay, minus 3x to the 11th power. Perfect. Okay, then we're going to plug in t squared.
So that's gonna be 3t fourth power minus 3t 10th power plus 3t 16 minus 3t 22.
Okay. And then g of x is the integral from 0 to x of f prime t squared dt. And I want to use that to estimate g at 1. So first...
So we integrate it.
Okay. First we're going to integrate f prime t squared dt. So if I do integrate, what's going to happen?
Yeah. So 3t fifth power over 5 11 power over 11 plus 17 over 17 and minus 3t 23 over 23.
Okay, I think you had that right, but do that one more time, only we're going to have x's, not t's.
Oh, so 3x fifth power over 5.
Okay, 3x to the fifth over 5, that's good.
Minus 3x 11th power over 11 plus 3x 17th power over 17 and 3 minus t 23rd over 23.
Minus 3x to the 23rd over 23, okay. So it's the first 4 non-zero terms of g of x. Okay, and I need to use that to estimate, I need to use the first 2 non-zero terms to estimate g1. Okay, so what's our estimate for g1 using the first 2 terms?
Oh, first 2 terms. Oh, so it's 3 over 5 minus 3 over 11.
Okay, common denominator?
So 55 and so 33 minus 3 over 50. No, 33 minus 15 over 55.
Okay, what's the answer?
So 18 over 33.
18 over...
33.
Not 33?
Oh, 55.
18 over 55. Okay, is your video still working or not?
It's kinda stopped, so
Yeah, that's kind of what I figured.
it worked, but it's not continuous.
Okay. So last part. We're told that the Maclaurin series G at x equals 1 is a convergent alternating series with individual terms that decrease in absolute value to 0. Show that the estimate in part C must differ by G1 by less than 1/5.
Oh, this one. I don't know how to start with.
Okay, so this is an error estimate. So what's the general form for an error estimate?
Oh, so Fn should be less than Fn plus 1.
Okay, so our error is our actual minus our estimate, right? Okay, so for us, that's going to be the absolute value of G1 minus our estimate for G1, which was 18 over 55. Okay, must be less than... What do we use to estimate error?
So the next term.
The next term. What's the next term for G1?
Oh, so that was 3x 17 over 17.
Okay, what's our x value?
So if you plug in 1, then it's gonna be x times 1 over 17.
Okay, so that'll be 3 over 17 total?
Oh yeah, 3 over 17.
Okay. So our error, that's G1 minus 18 over 55, must be less than 3 over 17. And we needed to prove that the error is less than 1/5. Is 3 over 17 less than 1/5?
Mm-hmm.
Okay, so the error must be less than 3 over 17. 3 over 17 is less than 1/5. And we should be good, I think.
Yay.
Okay, any questions on anything we did?
Nope.
All right. So we've got numbers 4 and 5 left for you today. Today's Thursday, so those are going to be due on Monday at 9 a.m.
Yay.
And we still got the physics homework that'll be due tomorrow. All right, so I will see you tomorrow at noon.
Bye.